So welcome everybody to this latest A2 level video on 162 maths, and in this video we'll be talking about trigonometry and introducing cosecant or cosec, secant which is sec, and cotangent which is cot. Now in basic trigonometry we were using sine, cos and tan, which was short for sine, cosine and tangent, to find missing lengths and interior angles in triangles amongst a lot of other things. Now reciprocal trigonometric functions cosecant, secant and cotangent, abbreviated as cosec, sec and tan, are defined as these following things. Now at A2 these are some new trig ratios that you need to be aware of. Now they are just a manipulation of ones that you're more used to, but you still need to understand what they actually represent, because obviously in a trig question you may get, rather than working with sine, cos and tan, you might instead get asked to work with cosecant, sec or cot, and you kind of need to understand what that actually is. Now one way of remembering these ratios is by looking at the third letter of the actual name. So from cosec the third letter is S, so there we have sine. The third letter in sec is C, and that's cos, and the third letter in cot is T, and that represents tan. So that's just a one way that most students, most teachers actually go on to remember these trig ratios. Now in terms of plotting values against y against theta gives the graphs of these functions, and these are something that you are going to need to know and be able to recognize. Now if you've got a graphic calculator, then that's going to be absolutely no problem. Sketching the graphs aren't going to be an issue, but there is an expectations on the syllabus that you do recognize these graphs. Now you also, along with the graphs, need to appreciate the properties of these graphs as well, which kind of, if you remember the graph, then learning these properties should be really part and parcel, so it's something that you don't have to sort of revise like a spelling test. So the function of fx of cosec x is periodic, so just like within all the trig graphs, that they just go on forever, both in both directions, so they all head towards infinity or minus infinity. The graph has a rotational symmetry about the origin of order 2. The range of f of x is greater than 1 and less than 1. So as you can see from this graph here, if I just pull a little dashed line, that it does tend towards above being 1 and below -1, like so. And the function of fx or cosec x is not defined when x is 0 degrees, plus or minus 180, plus or minus 360, or in radian mode it's going to be plus minus pi, plus minus 2 pi, etc. Now what that basically means is you're not going to get values at these here. So just like the tan graph, that there aren't any values at those particular values, and that obviously then continues with my green line. Now in terms of looking at the pi graph, again I have to use decimals, but that's going to be pi over 2, that's pi, that's 3 pi over 2, and that there is 2 pi, and again dashed lines at these values here, like so. And that's cosecant. So moving on to secant. So here again, graphs are very, very similar, which you would kind of expect simply because the cos graph and the sine graph are practically the same, just been slightly shifted, and this applies to the same as well. So again, in terms of the properties are very, very similar to cosecant. So looking at this then, we've got that the function of f of x of sec x is periodic, again of a period of 360 degrees or 2 pi radians. The graph is symmetric, it has symmetry about the y-axis, so again if I just put, let's say, a mirror here, it would be reflected, wouldn't be a problem. The range of f of x is greater than 1 or fx is less than -1, which again very, very similar to the cosecant graph. And the function fx equals sec x is not defined when x is 90, 270 plus minus, or in radians half pi or 3 pi over 2. So again we've got our lines, we're doing a different color rather than our symmetry line is here. And likewise the graph in terms of pi. So the only thing that changes regarding radians is just the horizontal axes, in which you just need to, I wouldn't really opt for decimals, I would just have to do this because of the software I was using to represent the graphs, but I would recommend that you write it as half pi or pi over 2 minus pi minus 3 pi over 2. And there, because obviously you can then, with rate, when you work in radians, you can get exact values. So looking at the cotangent graphs, again, very similar to the tan graph, which is in the point of it being completely different to the cos graph or the sine graph. It looks very similar to the tan graph, in which it does. Now the function of f of x cot x is periodic, so just like the ones before, it repeats itself, and it has a period of 180 degrees or pi radians. Now the graph has a rotational symmetry about the origin of order 2, and the range of f of x can take any real value. So again, just like with tan x, or if you're plotting the graph of tan x, it just goes all the way up to infinity. Now the function of f of x equals cot x is not defined when x is 0, 180, plus or minus 360, or plus minus pi, plus minus 2 pi. And again, all that means there is very similar, is the fact that we can't have values at here, because basically it's just going to be close to either minus infinity or positive infinity. And so that's all is there. Now, like I said, in terms of memorizing the properties, it's not really necessary, but what you do need to be able to do is recognize the graphs, and then once you recognize the graphs, you can then talk about it. You can see in terms of properties that I've mentioned here, in that fact that what we're mentioning is we're mentioning the period of the repeated pattern. We're talking about rotational symmetry, or the order of rotation. We're talking about the values of which you can have on the x and the y-axis, and values of where it's undefined. So if you are going to memorize the properties, they're the sort of 4 things that you need to be remembering. But like I said, I wouldn't really remember each individual property. As long as you remember the graph and you remember those 4 things to talk about, the rest will just fall into place.